Hello, we are Group 19 and our topic is auto-face doodling. At the very beginning, we find a very interesting dataset which is QuickDraw from Google. After exploring the data, we would like to learn can machine identify the categories and players, country, or region from the doodlings, and can machine automatically generate doodlings in a manner similar to human. Since human faces are variable in different regions of the world, we would like to narrow down our scope and choose face and facial features. So specifically, we would like to know, do the doodle faces and features show notable differences between different categories and different countries or cultures? And can machine learning models identify the differences? And can we train a machine to draw and generalize abstract concepts of face doodling? In addition, we would like to create a user interface which allows users to doodle face of facial features in a real-time way and present the results. So this is our structure of this presentation, and we begin with the exploratory data analysis to answer the first question. We load data from GCP storage and did some aggregation for the data, and we can see that there are around 94% of the drawings were recognized by the game QuickDraw, and there are over 200 countries, and the majority of the drawings are from the United States. And we can also see the distribution of the number of strokes and the average length of strokes. After ignoring part of outliers, we can see that for facial features, it usually takes less strokes to draw an ear or nose than the others. And the distributions of average length of strokes are positive good. And actually, there's no much differences among countries with regard to the stroke average statistics. So we further plot the average image for 11 selected countries and to see if there's any difference in terms of the average image. And we can actually see the notable difference like this one and here and the nose and eyes or mouth. So we further apply the TSNE, which is a machine learning algorithm for visualization high-dimensional data. And for the word category, we can see that there are three groups which are face, ear and nose, and eye and mouth. However, for a country, there's no clear boundaries among countries, whether for 11 countries or 4 countries. So we can answer this question like we can see that there's not much differences among countries in general, whether from the perspective of image or strokes. However, several countries do have notable differences among each other, and therefore we can do modeling based on this subset of countries. And in addition, facial features are identifiable using the data we have.
Based on our exploratory data analysis, we will build classification models to study whether machine can identify categories of doodlings and the countries of the drawers. As we could see from these doodlings, face and face features are absolutely different. We will never recognize a face as a mouth or ear. Based on this, we will expect that machine could be able to identify what categories of doodlings. We will use two models to do the image classification. One is random forest. We choose random forest as our base model since it has good accuracy among traditional machine learning algorithms and it runs very efficiently in large dataset compared to SVM or XGB. Then we will also build a CNN model. CNN is a class of deep neural networks that mostly commonly apply to analyzing image. Here on the right-hand side is our architecture of CNN. It has several convolutional layers followed by maximum pooling layers. Since the input format for both of the model are raster, we transform the vector drawing from our dataset to raster and feed them into the model. As we could see from the graph on the left-hand side, both models achieve good performance in this task. CNN outperformed random forest with a test dataset around 99%, and it does not have the problem of overfitting. On the right-hand side, from the confusion matrix, we could see although both models did a great job in identifying categories, it is relatively difficult to separate ear and nose, eye and mouth, which consistent to the TSNE result in our exploratory data analysis. Next, we would like to study could machine identify country information based on doodlings. Here, we randomly generate 5 face doodlings from 4 countries. From our human side, it is super hard for us to identify the drawer's country. So we want to try if machine learning could identify this information. Within each of the 5 word categories, we choose Australia, Brazil, South Korea, Saudi Arabia as the countries to identify, since the average doodling from these countries shows some difference based on our exploratory data analysis. We will use 2 deep learning models, CNN and RNN, to do this. We use RNN since we have the information about how people draw a graph in our dataset. We want to add this information to see if this will improve the prediction power. Here are the structure of our RNN and CNN. The structure of CNN is very similar to the previous one, and the RNN contains a convolutional layer and followed by a STM layer. For our model, we add the stroke information by changing the vector drawing format to a list of 3 by 1 dimensional sublist, which contains the x coordinate, y coordinate, and whether it is the end of the stroke. As we could see below, CNN outperforms RNN in every categories, and with over 43% accuracy. And this really surprised us. CNN did a good job in image area. So, for conclusion, we could see that machine learning models did a great job in identifying word categories. And as for countries, although our model only achieved over 40% accuracy, it is definitely better than random guess. We will see machine outperform human in this aspect.
Next, the question we would answer here is, can machine learning models automatically generate doodlings? We use GAN to answer this question. GAN are an architecture for training generative models, such as deep convolutional neural networks for generating images. The left part is a discriminator architecture, and the right part is the generator architecture. We can see from the GIF here, as the increase of the number of the epochs, the auto-doodle is more like real face doodlings. So the answer is yes, our GAN model could generate doodlings that can be recognized by people as the training epoch increases. And here is our demo part. Our demo allows users to doodle a face in a real-time way and present the recognition result of the category and the region from which the face or facial features could come. The framework of our system is just like that. We have a front end allows users to draw doodles and save the input as a PNG file. After that, the PNG file is processed into facial classification input and country classification input, and sent the input into 2 models, facial CNN saved model and the country CNN saved model, and combine the prediction output and send the output to the front end, allows users to see it. And here is our model. Here is our demo. When we draw a mouth here, it will say it's a mouth from Australia. And clear it, draw an eye. You see, it's an eye from Brazil. And the same as nose, ear, and face. So the conclusion here, machine can identify the category and player's country region from the doodlings. It can automatically generate doodlings in a manner similar to human. For the future steps, firstly, we would explore out of the scope of face and facial features to generalize the models to other word categories of drawings, and we would add more relevant functions to the demo and the web. and here's the reference. Thank you.